Hello and welcome back to College Algebra, MAT 150. In this lecture we're going to be discussing simplifying the inside of logarithmic expressions. So in the last lecture we were talking about the properties or laws of logarithms. In this lecture we're going to be continuing with that. And one of the other things we can do with the properties of these logarithms is to simplify the inside of the logarithm by rewriting the expression as multiple logarithms and bringing exponents of factors of the inside of the logarithm outside as a coefficient. So I like to sort of think about this as sort of pulling apart the logarithm, sort of expanding it, if you will. So, but it makes the insides definitely look more simplified. So here for this logarithm we have log. Remember, when there's no base actually written, and since logarithms have to have bases, it's assumed to be 10. So log base 10 of 7 times x is on the inside. So inside multiplication turns into outside addition. So log of 7 plus log of x. Similarly, in number 2, we have log base 2, but we have x times y. So inside multiplication turns into outside addition. Log base 2 of x plus log base 2 of y. We also have, again, exponents. So if there's an exponent on the inside, we can bring it out front. Here we have ln, which, by the way, is log base e. So we have 8 ln of x. So again, we can take the exponents, sort of move them out front. So 8 ln of x. Here we have ln of a squared times b squared. And on the inside, I just want to focus on this. Remember, order of operations is PEMDAS. Please excuse my dear Aunt Sally. Parentheses, then exponents. So we would take a raised to the second power and b raised to the fifth power before multiplying. So multiplying would be done last. So we have outside or inside multiplication turns into outside addition. And then we have squared into the fifth power. So we can take those exponents and put them out in front as coefficients. So 2 ln of a plus 5 ln of b. And we're done. And the insides of the logarithms are as simplified as we can make them. The next one, log base 3 of y over the square root of z. Well, this is division. So we have log base 3 of y minus log base 3 of the square root of z. Now, normally you would think this is, hey, this is done. But the inside of here is just y. And we have the square root, and then we're like, hey, there's no exponent. But remember that square roots can be rewritten as exponents. All right, so remember that if you have a square root, there's an index of 2 in the little divot of the square root there, and the z has an exponent of 1, and we can write this as we think about the exponent of z as the numerator and the index as the denominator. So that we have z to the 1/2 is the same as the square root of z. So if this was this denominator, so if this index was 3, we'd have a denominator of 3. If this exponent was, say, like 5, we'd have a numerator of 5. But with that, we now have rewritten this as an exponent so that we can pull the 1/2 out and write it as a coefficient in front of the logarithm. We have this. All right. And then number 6, we have log base 8 of 3x squared plus 7. And what's interesting is before we have inside multiplication, inside division, we have exponents. Here we have exponents, and I have multiplying 3 times x squared, but overall, I need everything to be multiplication, everything to already be factored. So here what we have are inside our two terms. And because of that, and because we can't factor this guy or somehow rewrite it, we say this is really simplified as much as we want to. There's not really much to be done. Okay? That concludes this lecture.